All right, welcome to this explainer. Today, we're diving straight into one of the most profound and rapid shifts in human history, the British Industrial Revolution. But look, we aren't just going to list off a bunch of famous inventions. We really want to get into the mechanics of how it actually happened. How exactly did Britain move beyond just a period of economic prosperity and trigger a compounding, virtually unstoppable industrial revolution?
So this is the core mystery we're trying to solve today. You see, prosperity is often just a plateau. An economy might be doing well, trade goes up, maybe people get a bit richer. But a true revolution, that requires a rapidly accelerating cycle. It needs a system that constantly feeds itself, getting faster and way more powerful with every single turn. To really grasp how Britain pulled this off, we need to talk about the flywheel effect. If you think about mechanics, a flywheel is this massive, heavy wheel that takes an enormous amount of energy just to start turning. But once it gets going, its momentum keeps it spinning, and it actually begins to generate its own power. The Industrial Revolution was essentially a massive macroeconomic chain reaction, a flywheel where geography, empire, mechanization, and transport didn't just add up, they exponentially accelerated each other. Let's look at exactly how this machine was built. Okay, let's dive right into part one, the spark, labor and capital. To get a giant flywheel turning, you need an initial spark. Specifically, you need labor, capital, and raw materials. And for Britain, this started right beneath their feet, with the land itself. Picture this. By the year 1699, an astonishing 71% of English land was already enclosed. Enclosure was basically the legal process of taking small landholdings and communal grazing areas, those commons where anyone could farm or forage, and fencing them off into large, privately owned, highly efficient commercial farms. Now, this enclosure process had a massive demographic consequence. As landowners consolidated their fields and started using much more efficient farming methods, well, they simply needed fewer workers. This displaced countless smallholders. With absolutely no land left to work, these dispossessed rural families had to migrate to the cities just to survive. And this mass rural flight created exactly what early factory owners were dreaming of, a captive, desperate, urban industrial reserve labor force, totally ready to work the newly invented machines. But laborers alone don't start a revolution, right? You also need raw materials and customers. Our sources highlight that Britain's dominant geopolitical position provided both of those things. The British Empire's Atlantic economy was heavily reliant on the labor of enslaved Africans in the Americas, and that system supplied the massive quantities of cheap raw cotton necessary to feed the British textile mills. In turn, Britain's colonial territories provided captive overseas markets, so they had the materials to build the products, and the global markets practically forced to buy them. The spark was officially struck. Which brings us to part two, the engine awakens. Cotton, coal, and steam. With all that labor waiting in the cities and cotton piling up at the ports, the engine truly awakens. Just listen to this explosive demand. 600 million pounds. Back in the 1770s, Britain was importing maybe 5 million pounds of raw cotton a year. By 1844, that number exploded to an estimated 600 million pounds. Because cotton fabric from India was wildly popular, the market demand was just massive. If Britain could somehow mechanize spinning and weaving to undercut those foreign producers, the market was basically limitless. It was this intense drive to mechanize cotton production that pushed inventors to create things like the spinning mule and the power loom. So, the absolutely crucial point here is how this desperate need for power triggered an incredible feedback loop. Those early textile machines relied on water power, but they outgrew that fast and needed steam. But how did they get it? Well, early steam engines were actually invented just to pump water out of deep coal mines. With the mines finally drained, Britain could extract vast amounts of cheap coal. That cheap coal was then baked into coke to smelt iron, completely removing their old reliance on scarce timber. And what did they do with all that cheap, abundant iron? They used it to build even better, stronger steam engines and factory machines. It's wild. Coal begat iron, iron begat steam engines, and steam engines begat more coal. To put that compounding cycle into perspective, just look at the massive leap in production. In 1740, British pig iron production was just a mere 17,000 tons. By 1834, fueled entirely by this new coke smelting process, it skyrocketed to nearly 700,000 tons. We aren't talking about incremental growth here. This was an exponential leap. Britain was literally forging the skeleton of the modern world.
Moving right along to part 3, the accelerator, the transport revolution. Now, mining millions of tons of coal and iron is great, but moving it required a total logistical overhaul. Before 1750, if you wanted to move goods by pack horse on these muddy, rutted roads, it cost about 1.24 shillings per ton mile. Prohibitively expensive. But this brilliantly illustrates the shift. When canals enter the picture, the cost drops to 0.20 shillings. And then, the ultimate game changer, rail freight drops the cost to just 0.09 shillings. Transport costs literally plummeted by over 90%. This rapid progression kicked off with the Bridgewater Canal in 1761, which was built specifically to cheaply move coal from the mines directly into Manchester. That drastically lowered fuel prices for the textile mills. Then, by applying steam power to locomotion, the Stockton and Darlington Railway opened in 1825. Just 5 years later, the Liverpool and Manchester Railway opened, the world's very first fully steam-operated intercity line. Suddenly, raw cotton is moving from the docks straight to the factory floors in hours instead of days. The flywheel was now spinning at maximum velocity. But we have to shift gears and look at part 4, the exhaust, the severe human toll. Because every massive engine produces exhaust, right? And the macroeconomic data often masks a very visceral, human-level reality. Listen to this direct quote from the Parliamentary Sadler Report of 1832. Matthew Crabtree, who had been a factory child from the age of 8, testified that he worked from 6 a.m. to 8 p.m. with only a single hour for a meal. To keep up with the relentless, unyielding speed of the steam-powered machinery, he recalled being beaten with wooden rollers and leather straps. Children were actually the preferred laborers. They were cheap, compliant, and small enough to physically crawl under the spinning machines. This exploitation was so extreme and the physical stunting of the working class was so painfully apparent that it eventually forced early government intervention. The Factory Act of 1833 was passed to introduce some basic regulations explicitly prohibiting the employment of kids under the age of 9 and capping the work week at 48 hours for those aged 9 to 13. Yet, actually scratch that, it wasn't a total fix. For a lot of working-class families struggling on starvation wages, even this reform was a mixed blessing, simply because they desperately needed their children's income to survive. And outside the factory walls, conditions were equally dire. That massive influx of displaced rural workers we talked about earlier created incredibly overcrowded, unsanitary urban hubs. City planning simply couldn't keep pace. Slums emerged where families were literally living among overflowing basement cesspits. This urban environmental crisis reached a boiling point during the Great Stink of 1858, when the summer heat baked the raw sewage lining the River Thames. The odor was so incredibly foul it completely disrupted Parliament.
Now, you might be wondering, didn't scientists at the time know what was making people so sick in these slums? Well, no, they didn't. The accepted Victorian science of the day was the miasma theory. They fully believed that terrifying diseases like cholera were airborne, transmitted by breathing in poisonous, foul-smelling vapors from rotting organic matter. And given how absolutely terrible London smelled at the time, you can kind of see why it was easy to just blame the air.
But the miasma theory was a deadly myth. While the establishment stubbornly clung to this idea of toxic air, Dr. John Snow conducted a brilliant investigation in 1854 in Soho, London. By painstakingly mapping out the deaths in the area, he proved that cholera was actually waterborne, transmitted by bacteria and contaminated public water pumps. It was a massive breakthrough that debunked the myth and forced the construction of modern intercepting sewer networks, which finally began to clean up the urban exhaust of this whole industrial machine. Finally, let's look at part 5, the unstoppable British flywheel. Bringing this all together into a broader geopolitical context, you really have to ask, why wasn't a powerful nation like France the first to industrialize? Well, our sources point out that France simply lacked Britain's highly specific interlocking advantages. Britain had abundant geologically accessible coal right next to their iron deposits. Plus, their earlier commercial success had led to relatively high wages, which created a massive financial incentive for owners to invent machines that could replace expensive human labor. Combine that with their dominance over the global cotton trade and their captive colonial markets, and Britain had a formula its competitors literally could not match. And honestly, this is the ultimate takeaway here. Britain's early lead locked in a self-reinforcing cycle. The sheer profits from those early factories paid for the R&D of the next generation of machines. The railways, which were initially just built for coal, ended up creating the entire modern engineering sector.
It was this relentless cycle of investment, innovation, and expansion that completely redefined global power and laid the absolute foundations for the modern capitalist economy we live in today. I want to leave you with one final thought. We've seen how the British industrial flywheel massively accelerated human progress, but it also came with staggering, often deeply hidden, human and environmental costs. As we stand today in the midst of our own rapid, compounding technological shifts, from AI to massive global supply chains, it's really worth asking, what are the modern flywheels we're building right now, and who exactly is paying the hidden costs today? Thanks so much for joining me on this explainer, and keep questioning the systems that build our world.